Hello everybody and welcome to page 26 of the workbook. So we are going to be looking at exercise 3 in this video. So let's read this together. Would like us to give an example of a set of four matrices in M 2 by 2 of R that are linearly dependent. Remember, this notation just means the set of all 2 by 2 matrices. Okay, so how could we do this? Well, basically, we would like there to be dependencies in this set of four matrices that we create. There are different ways to do this, but one way would just be to maybe start with three matrices and then make sure that the fourth matrix somehow depends on the previous three. Okay, I'm going to try to keep this as simple as possible. All right, so let's pick some matrices with a lot of zeros in them. Okay, so there's the first, second, and the third. Okay, and then to guarantee that this is a linearly independent set, what we could maybe do is to take our fourth matrix to be the sum of the three previous ones. So if you took these three matrices and added them together, what you would get is this. Okay, and just to make this a little easier to talk about, I'm going to name these matrices. Let's just call them B1 through B4. Okay, and let's just re-emphasize why it is that this example works. This set is linearly dependent. Okay, just that's kind of long to write, so I'm going to often use the abbreviation LD for linearly dependent. Okay, it's linearly dependent because of the fact that we created B4 by just adding up B1, B2, and B3. And that's what we've been calling a dependence relation. Okay, and you might notice one other thing with that. That dependence relation that we wrote above can be rewritten in the following form. Okay, so we could say it this way. This is equivalent to saying that I'm going to just take that equation that we wrote up here and get everything on one side of the equation. So 1b1 plus 1b2 plus 1b3 minus 1b4 is equal to 0, which in this case would be the zero matrix. Okay, and if you think about it, that would be illustrating using the definition that these four matrices are linearly dependent, okay? Because the numbers I'm circling, that constitutes a non-trivial solution to this equation that we have here. Okay, so we'll just finish this statement by saying this illustrates that a non-trivial linear combination of the four matrices equals the zero vector, which in this case is the zero matrix. Again, that just emphasizes again that this is sure enough, this is a linearly dependent set that we're talking about.